What's up guys, welcome back to the channel. Today we're going to be going through some more exam style Lin questions. Okay, so these are logarithms, exponentials, more on the exam style side of things. Just before I get started guys, if you enjoy this content, make sure to share, like, subscribe, turn notifications on, comment, like, it really helps out the channel. If you feel as someone who could gain some value from this, share it wherever, so everyone can get access to this type of content. But without further ado guys, let's get into it. So question 4, solve the equation 5 ln 4 minus 3x equals 6. Okay, cool. So it's a bit of a warm-up question, since it's going to get a little bit more difficult as we go further into this video. So let's start off by saying fine, we've got 5 ln 4 minus 3 to the x, okay, is equal to 6. Okay, so from here what I can say is ln of 4 minus 3 to the x is equals to 6 over 5, which gives me 1.2. Okay, now what I can do from here guys is that what I can say is that e to the ln of 4 minus 3 to the x is equal to e to the power of 1.2. Okay, so that's pretty simple. And then obviously e to the power of the ln, okay, so e to the power of ln x is just equal x, right? So I can therefore say that 4 minus 3 to the x, okay, is equal to e to the power of 1.2. Perfect. What does that tell me? Well, what that tells me guys is that 3 to the x then is equal to 4 minus e to the power of 1.2. Okay, so now I've got to solve for x. Okay, remember that's the key thing. So find the answer to 3 decimal places. So I can say, it's okay, fine, I can take ln both sides again. So ln of 3 to the x is equal to ln 4 minus e to the power of 1.2. Okay, which then tells me that x times ln 3 is equal to ln of 4 minus e to the power of 1.2. Okay, so x equals what? X is therefore going to equal ln of 4 minus e to the power of 1.2, okay, over ln 3. Okay, so therefore x is going to equal negative 0.351. Okay, and that guys is going to be the final answer for the first question. Just a quick recap, pretty simple standard question. Okay, you've got this 5 ln 4 minus 3x equals 6. Firstly you get rid of the 5, so we just got a ln equation. You then raise it to the power of e, and then from there we can solve for 4 minus 3 to the power of x. Okay, and we then take the ln of both sides. Okay, which gives us this. Alright guys, now question 5. Question 5 is the type of question you'll encounter on a more day-to-day basis when it comes to the actual exam. Okay, so as you can see, it's a chunky question, about 5 marks. But what does this question actually look like when you're solving it? I mean, because this is a standard question. So how are we going to do this? Well, first, let's read it. So variables x and y satisfy this equation. Okay, y squared is equal to a e to the power of kx. Cool. A and k are constants. Fine. Graph of ln y against x. Now, that's a key point here, guys, is that it's ln y. Okay? It's ln y against x. Okay? It's not y against x, it's ln y. Okay? You'll see why that's important in a moment. Okay, it's passing through these points. Okay, find the values of a and k. Let's do this in places. Fine. So how does one go about doing this? Well, firstly, what we've got here is y squared is equal to a e to the power of kx. Cool. Now, if I take the ln of both sides, what are we going to get? We get ln of y squared is equal to ln ae kx. Fine. And this then is the same thing as saying 2 ln y is equal to ln a plus ln e to the power of kx. Okay, now why is that the case? It's the case, guys, because of log rules. Okay. Remember, we've got the squared here. We're going to bring that down, so we get 2 ln y. Okay, for ln. Remember that rule. And then also, for ln a e k to the x, it's basically from the rule that, if I get this here, get the tail on it, ln a b is equal to ln a plus ln b, okay? So that's what we're going with here. Fine. And we can take this one step further. We can say 2 ln y is equal to kx ln e, okay, plus ln a. Alright, so what's ln e? Ln e is 1. So what we've got is ln y is equal to kx plus ln a. Another page here. Cool. Simple. So, what are the next steps here? Well, what we can say, alright, is we can say that ln y, okay, is going to equal k over 2 x plus half ln a. Okay, so now what we've got, guys, is the equation of the form they gave us. Okay, so what we've got now is the form that this graph is in. Okay, because remember, it's not y, it's ln y. Okay, it's ln y against x. So we say fine, we've got it in the form of y. Ln y is equal to mx plus c. Now what is m? M's the gradient. What's the gradient equal to? K over 2. But the gradient is also equal to the gradient that can be worked out via these two values. Okay, so how does that work? Well, say this. So the m, okay, is going to equal 2.7 minus 1.2. Okay, y1, y2 over 5.24, okay, minus 1.5, x1, x2. 5.24 minus 1.5. What does m equal then? Well, if we type that into our calculators, okay, that's going to give me 2. Okay, and what we're going to do is divide that by 0.24. Okay, so that's going to give me a value of 0.401. Cool. Brilliant. So now what we've got, guys, is we've got m, but we've also got m here. Now remember, k is a constant. So we're going to say, fine, well, k over 2 to 0.401. So I can therefore say that k, and by the way, this is the 3 significant figures, and I can say then from here that k is going to equal what? K is going to equal 0.802. Okay, cool. Now, remember, they want us to find a and k, so we found k. We got that. 0.802. But now we have to find a. Right, now how are we going to find a? Well, what we can say, guys, is ln y, okay, k is going to equal what? So we just sub this in. It's going to equal what? 0.401 x plus half ln a. And that's just a simple case of pretty much just plugging in values. Okay, so what I'm going to plug in is 1.5, 1.2. Okay, when we plug these in, we're going to be able to find A. And now remember, this is ln y. Ln, so let me get that right. Ln y, not y, okay? So what we're going to get is 1.5, sorry, 1.2. Okay, 1.2 is equal to 0.401, okay, times 1.5 plus half ln a, right? And now from here, I can therefore say that ln a is going to equal 1.197. Okay, so what's a going to equal then? Well, a can therefore equal 3.31. Okay. So we've got A, we've got K, so we have solved this question sufficiently. Alright guys, now for question 6, okay, we've got time to solve the equation ln 1 plus e to the power of negative 3x is equal to 2. And it wants us to give the answer to 3 decimal places. So how are we going to do that? What I'm going to say, firstly, is I'm going to say fine. Ln 1 plus e to negative 3x is equal to 2. What we can do from here is pretty simple. You just raise it to the power of e. Okay, so again, this is a pretty standard question. Okay, so we then get 1 plus e to negative 3x is equal to e to the 2. And I can therefore say that e to negative 3x is equal to e squared minus 1. Okay, now let's take ln of both sides. So ln of e to the negative 3x is equal to ln e squared minus 1. Therefore, I could say negative 3x ln e is equal to ln of e squared minus 1. But remember, ln e is equal to 1. So I've got negative 3x is equal to ln of e squared minus 1. So what can I say? I can say then that x, okay, is going to equal ln e squared minus 1 over negative 3, which means that x is going to equal what? Well, x is going to equal negative 0.618 then. Okay. Pretty standard question, guys. So this here is going to be our final answer. Alright, now question 7 is pretty standard as well. So basically what we got is these variables satisfy this relationship. Okay. By taking logarithm, show that the graph of y against x is a straight line. Right. So what we got here, guys, is 2 to the power y is equal to 3 to the power of 1 minus 2x. Right. So now what we want to do is we want to take the ln of both sides. So I can say ln 2 to the y is equal to ln 3 to the power of 1 minus 2x. Okay, so then what I then get, guys, is y ln 2 is equal to 1 minus 2x ln 3. Okay, cool. Where do we go from here? Well, what I'm going to do is I'm going to span this out. So y ln 2 is equal to ln 3 minus 2 ln 3 x. Okay. In fact, I think it looks better if I just say 2x ln 3, just to keep things simple. Okay, 2x ln 3. Now, from here, what I can say is, okay, cool, y is equal to ln 3 over ln 2 minus ln 3 over ln 2, okay, times 2x. So really it's 2 ln 3 x. Okay, so if we rearrange this now, guys, what we get is minus 2 ln 3 ln 2x plus ln 3 over ln 2. Cool. Now, this here is in the form, okay, is in form y is equal to mx plus c. So what does that tell me? Therefore, the graph is a straight line, guys. Okay. And so therefore, gradient is equal to negative 2 ln 3 over ln 2. Cool. Now for B. What do I want us to do for B? Find the exact x coordinates of the point of intersection of this line with the line of the line minus 3x. Okay, so that's pretty easy. All we have to do in this situation is say, fine, y is equal to 3x. Okay. That's the one. And the other is okay, so got y is equal to 3x. And the other answer, okay, so y equals 3x. Okay, and we got y is equal to minus 2 ln 3 over ln 2. Okay. Okay, so it's an intersection here. So you've got y equals 3x intersecting with this over here. So all we need to do now, guys, is solve them simultaneously. So I can say 3x negative 2 ln 3 ln 2. Okay. X plus ln 3 over ln 2. Okay, now if I want to solve this now, I can say the following. I can say that 3x, okay, 3x is the same thing as saying negative 2 ln 3. Okay, x plus ln 3 over ln 2. Okay, so I can therefore say that 3x ln 2 is equal to negative 2 ln 3 x plus ln 3. Okay, fine. What can I do here? Well, I can plus it over. So 3x ln 2 plus 2 ln 3 x is equal to ln 3. What can I do now? Well, I can take out the common factor of x. So I can say x 3 ln 2 plus 2 ln 3 is equal to ln 3. But then from here, guys, it's just a case of saying, well, look, x is going to equal ln 3 over 3 ln 2 plus 2 ln 3, which means that x is going to equal ln 3. Do I want to simplify it in a certain way? Ln a over ln b. Okay. So ln 3. Okay, and it's the same thing as saying ln 2 to the 3 plus ln 3 squared. Okay, remember log rules. Right, so we get ln 9 plus, sorry, ln 8 plus ln 9. So ln 3 over ln 8 times 9, which is equal to ln 3 over ln of 72. And that, guys, is going to be your final answer for that question.